Hello everyone, welcome to Genius channel. We are going to see some previous year Nda Maths questions. See the question number 15. If alpha and beta are different complex numbers with modulus of alpha is equal to 1, then what is modulus of alpha minus beta by 1 minus alpha beta conjugate beta bar equal to? Alpha and beta are different complex numbers with modulus of alpha is equal to 1. Then what is modulus of alpha minus beta by 1 minus alpha beta bar equal to? Please try all of you. So here what I'm going to do is, I'm going to take this expression alpha minus beta by 1 minus alpha beta bar all modulus. See, I know alpha bar, that is what is 1. Alpha bar is 1. So I'm going to replace this one using alpha bar. So alpha bar minus alpha beta bar. Okay. Now, what I can do, I can take this alpha bar, alpha common, isn't it? Alpha common from this. So this will become alpha minus beta by, if I take alpha common, this will become alpha bar minus beta bar. So from this, what I'm going to do is I'm going to take 1 by modulus of alpha outside. Then what I have 1 alpha minus beta by alpha bar minus beta bar, isn't it? Alpha bar minus beta bar. So this one I can write it as 1 by modulus of alpha minus beta divided by alpha minus beta, the whole bar, isn't it? Okay, now listen, I know that modulus of alpha is equal to modulus of alpha bar, isn't it? Modulus of alpha is equal to modulus of alpha bar, that we have already studied. Modulus of alpha is equal to modulus of alpha bar. Okay, so here that means if we find out the modulus of the conjugate, that will be equal to the modulus of the complex number itself. So this I can cancel. I'll get 1 by modulus of alpha. What is modulus of alpha? They have given modulus of alpha as 1. So 1 by 1, answer is 1, option C. Option C is the correct answer. Okay, so please go through, copy down this. Now see the question number 18. What is I raised to 1000 plus I raised to 1001 plus I raised to 1002 plus I raised to 1003 equal to, where I is equal to root of minus 1? Let's try all of you. Easy question now. You have to just do I raised to 1000 plus I raised to 1001 plus I raised to 1002 plus I raised to 1003. So if you want, you can take I raised to 1000 common. So that will be 1 plus I square plus I cube, isn't it? Now what is this? I raised to 1000 into 1 plus I plus what is I square, that is minus 1, plus what is I cube, minus 1 into I, that is minus I. So that is 1 minus 1 will go, I minus I will go. So I raised to 1000 into 0, that is 0. Option A. Very easy question. Also we know that sum of the 4 consecutive powers of I will be always 0. That means I raised to 0 plus I raised to 1 plus I raised to 2 plus I raised to 3. That will be 0. Next consecutive multiples, if I am taking I raised to 4 plus I raised to 5 plus I raised to 6 plus I raised to 7. That will be 0. So sum of the 4 consecutive multiples powers of I, if we add, you will be always getting as 0. That results also we can directly use here. Okay. So going to the question number 19. Question number 19. What is 1 by log to the base 2n plus log to the base 3n plus etc. up to log to the base 100 n equal to? So earlier we have seen a question similar to this. So can you try yourself? It's just similar to the same property we have used. That is 1 by log to the base ab is equal to log to the base ba. Remember this rule? Apply this rule in each term. So this can be rewritten as log to the base n 2 plus log to the base n 3 plus etc. up to log to the base n 100. So next apply the same thing we have done in that same question. Log a plus log b, what is that? That is log ab. So here we can write log to the base n 2 into 3 into 4 into etc. up to 100, isn't it? So what is that? This is 100 factorial, isn't it? 1 into 2 into 3 into 4 into etc. up to 100, that is 100 factorial. So log to the base n 100 factorial, isn't it? Or we can rewrite as 1 by log to the base 100 factorial n. 100 factorial n. So which is that? Option A. 1 by log to the base 100 factorial n. Same type we have seen in the previous video. Same steps, no difference. So you can note this as important because repeatedly being asked this, applying the same property repeatedly asked you. Okay, so moving to the question number 22. What is the greatest integer among the following by which number 5 raised to 5 plus 7 raised to 5 is divisible? What is the greatest integer among the following that this is divisible? Okay. So if you don't know, please note, if in x raised to m plus y raised to m, listen, in x raised to m plus y raised to m, if m is odd, then x raised to m plus y raised to m will be divisible by x plus y, will be divisible by x plus y. See, in the expression x raised to m plus y raised to m, if m is odd, x raised to m plus y raised to m will be divisible by x plus y. So here see, 5 is odd, isn't it? 5 is odd. That means this power is odd. So this 5 raised to 5 plus 7 raised to 5 will be divisible by 5 plus 7. That is, it will be divisible by 5 plus 7. That is x plus y. That is 12. So answer is option D, 12. Option D, 12. Okay. So moving to the question number 23 now. Question number 23. If x is equal to 1 minus y plus y square minus y cube plus etc. up to infinite terms, where modulus of y less than 1, then which one of the following is correct? Okay, so what they have given, x is equal to 1 minus y plus y square minus y cube plus etc. Then which is correct? Which is correct? So this is a GP, isn't it? This is a GP. Why? Because this is y raised to 0, y raised to 1, y raised to 2, y raised to 3, y raised to 4, etc. Isn't it? Okay, so we can write it as negative y because negative y raised to 1, negative y raised to 2, negative y raised to 3, negative y raised to 4, like that this sequence is going. So this is a GP. It has a common ratio. Just like AR square, AR cube, like that. So what is the sum of a GP up to infinite terms? What is the sum of the GP up to infinite terms? Sum is A by 1 minus R. A by 1 minus R. A by 1 minus R. So here what is A? A is 1, isn't it? A means first term. So here first term is 1. So sum is equal to first term is 1 by 1 minus R. What is R? R is what is here? R. R is what? R is A2 divided by A1. Okay. So here A2. Second term is minus y divided by A2 is 1. So what is R? R is minus y. So minus y. So the answer is 1 by 1 plus y. Sum is 1 by 1 plus y. Isn't it? So option A, 1 by 1 plus y. Option A is the correct answer. So moving to the next question. Question number 20. Question number 20. The modulus amplitude form of root 3 plus I, where I is equal to root of minus 1. Okay, so modulus amplitude form means the polar form that we are studying from the NCERT textbook. Polar form, isn't it? R cos theta plus I sin theta. Remember the polar form? Okay, same form they are meaning as modulus amplitude form. Modulus amplitude form. So complex number is root 3 plus I. So what is modulus? This complex number z is equal to root 3 plus I. So modulus of z is root of x square plus y square. That is root of root 3 square plus 1 square. So root 4, that is 2. Okay. Then how to find theta? Theta is equal to tan inverse y by x. That is tan inverse 1 by root 3. So that is tan inverse 1 by root 3 is 30 degree or pi by 6. Okay, so write in this form. So it is r cos theta plus I sin theta. So r is 2 cos theta means cos pi by 6 plus I sin pi by 6. Cos pi by 6 plus I sin pi by 6. So what is the answer? Option B. Option B is the correct answer. See the next question. Question number 21. Question number 21. What is the number of non-zero terms in the expansion of 1 plus 2 root 3x the whole raised to 11 plus 1 minus 2 root 3x the whole raised to 11 after simplification? What is the number of non-zero terms? Number of non-zero terms. See, listen. So here you have to by heart two conditions. If we are given with a question like a plus b the whole raised to n plus a minus b the whole raised to n. A plus b the whole raised to n plus a minus b the whole raised to n. Then if n is even, the number of terms will be n plus 2 by 2. Number of terms will be n plus 2 by 2. If n is odd, number of terms will be n plus 1 by 2. Okay, so if n is odd, even, number of terms will be n plus 2 by 2. If n is odd, number of terms will be n plus 1 by 2. Here n is odd, isn't it? N is odd. So number of terms will be n plus 1 by 2. So what is n here? N is equal to 11. So n plus 1 by 2. That is 11 plus 1 by 2. So 12 by 2. So for totally 6 terms. 6 terms. That is option C. 6 terms. Option C is the correct answer. So by heart this, if we are asked to expand this one, you have to know these two conditions. When n is even, n plus 2 by 2, n is odd means n plus 1 by 2. Okay. So moving on to the question number 25 now. 25. If A is a 2 by 3 matrix, AB is a 2 by 5 matrix. B must be what? What is the order of B matrix? So we know if we can multiply two matrix only if it is like number of columns of the first matrix is equal to number of rows of the second matrix. If number of columns of first matrix equal to number of rows of second matrix, only we can multiply these two matrix and we'll get AB as M by P, the remaining order. So we can multiply only if the number of columns of first matrix equal to number of rows of second matrix. So here, see, AB is 2 by 5. So A is, order of A is 2 by 3. So B should be starting with 3. Then only its rows should be 3. Then only we can find out, isn't it? We'll get the answer. So M by P is what? Here we got as 2 by 5. So this should be 3 by 5. Then only number of columns of the first matrix equal to number of rows of the second matrix. Then remaining order 2 by 5 will come as the answer. Here for AB matrix it is 2 by 5. So it is the B matrix should be 3 by 5. B matrix is 3 by 5. Order of 3 by 5. Okay. So thanks for watching Genius channel. We'll see in another class with more videos. Thank you so much.